Hey everybody, we've been talking a lot about how to balance redox reactions, both in acidic and basic solution. In this lesson, we're going to work some examples from the Wiley homework. We'll do a quick review of balancing the redox reaction steps. Then we're going to go over two problems from Wiley assignment 5614QA. We'll do problem 14-19 and 14-21. So previous videos have talked about the steps toward balancing redox reactions. We're going to go over those quickly now. If you are unsure of how to do that, feel free to either look at the reading or view those previous videos again. First step we will do is assign oxidation numbers to all atoms in the reactants and products. That's going to tell us which atoms are gaining electrons and which are losing electrons. We will then split the reaction into half reactions and balance each half reaction separately. We first balance all atoms except hydrogen and oxygen. Balance the oxygen by placing H2O. Balance hydrogen by placing H+. We will then place electrons to balance the charges. After mass and charge on the half reaction are balanced, we will recombine the half reactions, multiplying by a constant if necessary to cancel electrons. The whole purpose of balancing redox reactions is to cancel electrons. If the reaction is in basic solution, we will then add OH- to both sides to cancel H+. If it's an acidic solution, then we're done after we recombine and cancel. Let's look at Wiley problem 14-19. Now all of the questions in this problem are half reactions only. As you work these, you don't have to separate into half reactions, you don't have to combine and cancel. 14-19 gives you practice in balancing the individual half reactions. Let's look at one. P4 going to phosphoric acid, H3PO4. They don't specify acidic or basic solution, and I'm just going to do acidic. So the first thing we will do is assign oxidation numbers. Phosphorus is an element, whether it's just P or P4, so that oxidation number is 0. For the products, we know oxygen's a -2, hydrogen is a +1. To figure out the phosphorus, we're going to have to do a little bit of math. We know that the sum of all the oxidation numbers in this molecule is 0 because it's neutral. So we're going to have to do a little algebra to figure out what the oxidation number for the phosphorus is. We have 3 times the +1 of hydrogen, plus phosphorus's oxidation number, plus 4 times -2 for the oxygen. That all adds up to 0. When I do that algebra, P equals +5. My oxidation number for phosphorus, +5. That tells us that each phosphorus atom is losing 5 electrons, going from a 0 oxidation state to +5. Now let's move on to balancing. First we will balance the phosphorus atoms. There are 4 on the left and only 1 on the right, so we have to put a 4 coefficient in front of the phosphoric acid. We'll balance oxygens by adding water. We have 16 oxygens on the right hand side, which means we're going to have to add 16 waters on the left. That seems like a lot, but it's what we need to do. Next, we will balance the hydrogens by adding H+. We have 32 hydrogens on the left and 12 on the right. That means we have to add 20 H+'s to make our hydrogens equal. Finally, we balance the charge by adding electrons. We are neutral on the left-hand side, and we have a +20 charge on the right. That means we have to add 20 electrons to the left side. Check our mass and our charge. 32 hydrogens on the left, 12 plus 20, 32 on the right. 16 oxygens on the left, 16 oxygens on the right from 4 PO4s. 4 phosphorus on the left, 4 on the right. We're done. Neutral on the left, plus 20 and minus 20 are charges, neutral on the right. We are balanced. That was a messy one. If you encounter large numbers like this, don't be afraid. We had lots of water, lots of H+, lots of electrons. Take your time, follow the steps. If this is the answer you get, mass and charge balance, and you have your lowest numbers, you can't divide through by a number to reduce them, you've got the right answer. You're okay. Practice will make these problems much less intimidating. So some hints, you might have seen this on the previous video. I think it's good to put in again. You will usually add H+ to the opposite side where you add waters. You will also usually add electrons to the same side that you add H+. If you see these as you work the problems, it means you're on the right track. There might be exceptions, but I haven't found any yet. So use these hints to help you as you work the problems. Let's do another one. 14-21. There is our redox reaction. This is a full redox reaction, and we're going to have to break it into half reactions and recombine. The H+ tells us we have acidic solution. Also, when I'm balancing the half reactions, I'm going to ignore the H+. I'm also going to ignore the water. We're going to be adding water at some point anyway. I'm not going to start with it already there. And that way I don't have to worry which half reaction to add H+ or water to. I think Wiley just does it to show us we're aqueous solution and we're acidic. So first we will assign oxidation numbers. Okay, manganese 2+ is a +2. -2 for the oxygen in the bismuth-8 anion. That means the bismuth is +5. Our hydrogen is +1. For the permanganate, oxygen -2, manganese +7. Bismuth +3 is 3+. Oxygen -2, hydrogen +1. Based on the oxidation numbers, our half reactions are manganese 2+ going to the permanganate and the bismuth-8 going to bismuth 3+. So let's start by balancing the manganese half reaction. The manganese atoms are already balanced. Let's balance the oxygen by adding 4 waters on the left-hand side. That gives us this half reaction. Add 8H+ to the right-hand side because we've got 8 hydrogens on the left. Okay, we're going to add 5 electrons to the right, and that will balance our charge. We've got a +2 charge on the left, and we have a +7 on the right. 5 electrons will balance our charge. Check mass and charge to make sure everything is balanced. I've got 8 hydrogens on the left, 8 on the right, 4 oxygens on the left, 4 on the right, 1 manganese on the left, 1 on the right, a +2 charge on the left, and a -1 +7 -5 +2 charge on the right. This half reaction is balanced. Now the next half reaction. The bismuth atoms are already balanced. Balance oxygen by adding 3 waters to the right. Add 6H+ to the left to balance the 6 hydrogens that were on the right. Charge is balanced by adding 2 electrons to the left. We've got a +3 on the right, +6 minus 1. We have to add 2 electrons to the left. Check our mass and charge. 6 hydrogens on the left, 6 on the right. 3 oxygens on the left, 3 oxygens on the right. We have a +3 on the left, +3 on the right. We're done with this half reaction anyway. So there are our balanced half reactions. Electrons are on opposite sides, which is good, but right now they're not going to cancel. The whole purpose of balancing redox reactions is to cancel electrons. We're going to have to multiply the manganese half reaction by 2 and the bismuthate half reaction by 5. That will give us 10 electrons on opposite sides. Okay, I multiply through everything by 2. The other half reaction, multiply through everything by 5. Now as you work this problem yourself, be sure to take your time. This shows you how to do it, but make sure you go through and do this all yourself. Now we can combine our half reaction, canceling electrons, and anything else. It looks like some water and some H pluses will cancel as well. Let's look at that. Electrons cancel. Great. Okay, 8 waters cancel on the left, canceling with the 15 in the other half reaction, giving us 7 waters on the right. Our H pluses cancel in the first half reaction, giving us 14 H plus in the second half reaction. So our final balanced redox reaction is, okay, the 2 manganese, the 5 bismuthate, 14 H plus, 2 permanganate, 5 bismuth, and 7 waters. Checking mass and charge, we see everything is balanced. Boy, are they all this tough? Well, not all of them, but some of them are like this. So make sure to work these on your own. And if you have to go through a few times, that's all right. Train with this. The more you practice, the easier they will become. The main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.